Good morning friends, this is Ashwini Singh and today I'll be discussing the topic on geometry and mensuration, that is, let us say, part 3, in which I'll be giving you certain formulae for geometry, right? Okay, and then we'll be using their application, or we'll be applying them in our fourth part. So first is the concept of straight lines. We are having a straight line segments over here, and if these lines are at equal distance, that means they are parallel. And if these lines are cut by any third side intersecting these two lines, it is known as transversal. So parallel lines, transversal lines, you already know. Next is, in terms of angles, we are going for something. Let us say we are having two parallel lines. So this angle 1 and this angle 5, they are known as corresponding angles. Similarly, angle 2 and angle 6 are known as corresponding angles. Angle 3 and angle 7 are known as corresponding angles, and angle 4 and angle 8 are known as corresponding angles, and corresponding angles are equal. That is first thing. Secondly, we are having alternate interior angles. So this angle 4 and angle 6 are alternate interior angles. Similarly, 3 and 5 are alternate interior angles. Right? These are also equal. Angle 4 is equal to 6, 5 is equal to 3. Then alternate exterior angles, that means 1 and 7, 2 and 8. So 1 is equal to 7, 2 is equal to 8, correct? And angles on the same side are supplementary. That means angle 4 plus angle 5 is equal to angle 3 plus angle 6 is equal to 180. Very easy. Now talking about certain figures which are known as polygons. Polygons, all of you know what is polygon. Polygon is a many-sided figure. Polygon is a many-sided figure, correct? So let us see some formulae for polygons also. So we are having a polygon, that means a figure enclosed by certain sides. If these sides are equal, this is equal to this, 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 then this figure is known as a regular polygon. And then we have another name as a concave polygon. Concave means if all the diagonals are inside. So these are the diagonals. They are inside this polygon. So this polygon is a concave polygon, regular polygon. Now let us see certain properties. Sum of all interior angles of n-sided polygon is n minus 2 into 180. So let us say we are having a polygon of 4 sides. So in this case, n is equal to 4. Right? So what is the sum? N minus 2. That means 4 minus 2 is equal to 2 into 180. And we get the sum as 360 degrees, that you already know, correct? Similarly, sum of all exterior angles is equal to 360. All exterior angles is equal to 360. Number of sides is equal to 360 upon exterior angle. This we need to know, 360 upon exterior angle, right? And area is equal to, area of this polygon is equal to ns square upon 4 into cot 180 by n. So what is n? N is the number of sides. So if we are having a 6-sided polygon, n is equal to 6. And what is this s? S is the length of a side. Because it is a regular polygon, the length of all sides will be same. So s refer to the side length and n refer to the number of lines enclosing the figure. So s is equal to length and n is equal to number of sides. Now let us come to properties of triangle. So again it is very easy. We can see we are having a triangle over here and we are having a circle inside with a small r written over here. The small r is in radius. That means it is radius of circle inscribed in this triangle. And if this is known as r, capital R, that means from center to any vertex, this length is equal to r. If I draw a circle, this circle will touch all these vertices A, B and C. So this center, this radius is called the circumradius and this r is called the inradius. Now we can see certain formula over here in terms of sine and cos relating these sides and angles. So A upon sine A is equal to B upon sine C is equal to C upon sine C is equal to 2R. R is the circumradius and A is the side, A is the angle. So A is the side corresponding to the angle which is against that side. So this side is A, opposite angle is A. This side is C, opposite angle is C. This side is B, opposite angle is B. So capital A, B, C for angles and small a, b, c for our sides. So next formula in terms of cos is equal to a square is equal to b square plus c square minus 2bc cos a. So A square is equal to B square plus C square minus 2BC cos A. Similarly, I can have B square is equal to C square plus A square minus 2AC cos B. Right? Similarly, I can have C square is equal to A square plus B square minus 2AB cos C. Simple as that. Now third is, what is the area? Area is half AB into sin C. Half of multiplication of length of two sides into the sine of angle which is enclosed. So this is A, this is B. So area is equal to half into A into B, and the angle over is C. So half AB sin C, or it can be half AC sin B, or it can be half BC sin A. Simple. Area we also know the half base into height. This is the general formula. And next formula for area we already know. We have discussed in the previous lecture. A is equal to under root SS minus A, S minus B, S minus C, where A, B, C are the side and S is the semi-perimeter. And this is known as the Hero's formula that we know already. Hero's formula. Then area is equal to RS in terms of this small r in radius, and area is equal to ABC upon 4r in terms of this external radius, circumradius. Okay. Now let us say see similarity of triangles. We are having certain congruent triangles, we are having similar triangles. Congruent means exactly equal, and similarity means they can vary in their scale. So we know what is the equilateral triangle, we know isosceles. Today we will discuss this importance of this triangle, that is a right angle triangle. So we are having a right angle over here, and we are having a triangle as ABC with sides A, B and C, and we are having a perpendicular drawn from this side A onto this vertex A to meet this vertex A. It means from A we have drawn a perpendicular, right? So which is cutting this BC in ratio Q is to P. So in this we can use the Pythagoras theorem, and you already know A square is equal to B square plus C square. A square is equal to B square plus C square with the help of Pythagoras theorem. We also know that area is equal to RS, this we already know, and S is equal to A plus B plus C upon 2, this is a semi-perimeter. And we also know that area is equal to half base into height. So over here, what is the base? Base is C. What is the height? Height is B. So using this and this, we get the relation between the small r and S. The small r is equal to BC upon 2S. That need to be remembered. Secondly, we have derived certain things. So this is derived, this is derived. I will not go into the details, but these need to be taken care of. So what is C square? C square is equal to P into A. What is B square? B square is equal to Q into A. What is AD square? AD square is equal to Q into P. These need to be remembered. Now we have certain more terms which need to be identified. First is the median. So let us say we are having a triangle PQR, and what we are doing from this vertex, we are drawing a line which will bisect this QR. From Q we are drawing a line which will bisect this PR, right? And from this R we are drawing a line RE that will bisect this PQ. So these lines are called medians, and where these medians meet, this is known as centroid. So it is a centroid, and a median divides the triangle into two equal parts. So this part is equal to this part if PG is the median, right? And this median, this centroid divides itself, the median ratio 2:1, 2:1, 2:1. It need to be remembered. Now, coming to a very important formula, this need to be learned with respect to the medians. That's often asked, that is very frequently asked in your exams. Questions based rather. So it is twice into median square plus twice into half of third side square is equal to sum of square of other two sides. So taking case of is this triangle, so it's something like this, twice into median square. Let us say this PG median. So twice into PG square plus twice into third side. So if this is one side, this is median, this is third side. If this is median, this is third side. If this is median, this is third side. So plus twice into half of third side. Half of third side means half of QR square. Half of QR square is equal to sum of square of other two sides. So other two sides are PQ, PR. So it is equal to PQ square plus PR square. Correct? So this formula need to be remembered. Okay. Now we are having a triangle as A, B and C, and we have perpendiculars drawn from B to AC, similarly from C to AB, and where these perpendiculars meet, it is known as orthocenter. So O for orthocenter. So where the perpendicular meet or height meet, it is known as the orthocenter. And this property need to be known, that angle A plus angle BOC is equal to 180 degree. Similarly, angle B plus angle AOC is equal to 180 degree, and so on. So from examination of point of view, this need to be known, because it is derived, but it will not be derived in your exam. It will be used rather, application. Now again we are having a triangle. We are drawing perpendicular bisectors of all the sides, and where these bisectors meet, this point is known as circumcenter, because taking this C and taking it to one vertex, this as a radius, I can draw a circle, and that circle will touch all these PQR points. So this is a circumradius, and this is a circle, and this is a circumradius. And the property over here need to be known as angle QCR. That means this segment, this angle is twice the angle at the circumference. So angle QCR is equal to twice angle QPR. So this need to be remembered. This need to be remembered. Now third case, let us discuss regarding the incenter. So what is incenter? If I bisect angles, so if this angle is 60 degrees, the bisector is 30 degrees. If it is 80 degrees, it will be 40 degrees. So if we join the internal bisectors of the angles, they'll meet at a point, and from that point, if I can touch this line and draw a circle, it will be touching all these lines. So this will be in radius small r, and this center is called the incenter. And the property for this incenter again need to be known by you, that is angle QIR. Angle QIR is equal to 90 plus half angle P. So let us say angle QIR is equal to 60. So sorry, let us say this angle is 60, P is 60. So what is the angle QIR? QIR is equal to 90 plus half angle P, that is equal to 30. So angle QIR is equal to 120 degree. Anyway, this need to be known first. Correct? These two things we already know. Theta 1 plus theta 2 is equal to 180. So they are known as supplementary angles. This term need to be identified. Similarly, if the sum of two angles is equal to 90, so that means they are complementary angles. Correct? Now, there is a relation between ratio of areas of two similar triangles. So we are having similar triangles over here. That means there will be certain ratio between the sides. Correct? There will be ratio between their altitudes, and there will be a ratio between their medians. So we can see over here from this part, this is first triangle, this is second triangle. AB upon PQ is equal to AC upon PR is equal to BC upon QR is equal to BE upon QI is equal to AD upon PS. So all this is equal. And the relation between areas is area of first is equal, the ratio of area of two similar triangles is equal to the ratio of squares of corresponding sides. So area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square is equal to AC square upon PR square is equal to BC square upon QR square. Correct? Now let us see some more properties of certain other things. We are having a quadrilateral over here. It touches the circle, and the vertices of this quadrilateral are on the circumference. So in this case, our property is the product of diagonals AC into BD is equal to the sum of product of opposite sides. So AC into BD is equal to A into C plus D into B. So these are two sides. These are two sides. So A into C plus B into D is equal to this into this. Correct? This is convex quadrilateral. Okay. Now, circle. We are having a circle over here, and we can see a sector. Sector means it is a portion of a circle whose area can be found out. And we are having a theta over here. and over here this xy. If I draw a line xy, it is called a chord. So a chord is a line that touches the circumference on 2 points. It is a chord, correct? And we are having xy, the arc over here. We'll be having another arc xy over here. But this is a major arc and this is a minor arc. And this is called the segment, correct? Now, again a quadrilateral, cyclic quadrilateral. We can see in this case again some property need to be discussed. Opposite angles are supplementary. That means angle A plus angle C is equal to 180. Similarly, angle D plus angle B is equal to 180. And this exterior angle is equal to the vertically opposite interior angle. Angle X is equal to angle A. That's simple, right? So let us say this angle is X. So this angle will be 180 minus X. So what will this angle be? X. So angle X is equal to angle X is equal to angle A, correct? Now regarding chord, again we will discuss certain properties. So we are having a circle and we are having a chord PQ. So if we draw perpendicular from midpoint from center to this chord, it will divide this chord, will bisect this, perpendicular will bisect the chord. So this, let us say this point X, PX is equal to XQ. Similarly, in other properties, if we are having a circle and we are having chords which are at equal distance, they are of equal length, correct? So if you are in two chords that are at a distance of, let us say, 5 centimeter each, the length of these will be equal. AB is equal to CD. Similarly, if we are having two chords and the angle they make at the center, these vertically opposite angles are equal, correct? Okay. Fourth property regarding chords. We are having two chords AB and CD. This is B, this is D, and they meet at external point P. So the property over here is the multiplication of the chord length or the length from point P, that is PA into PB, is equal to PC into PD. So PA into PB is equal to PC into PD, where P is the external point. So this length into this length is equal to this length into this length. This point can be inside or this point can be outside. So we can see over here this point is inside. So that means this length into this length is equal to this length into this length, right? So it is uniform. Next, if we are having a circle over here and from outside we draw two lines that touches this circumference, this line is called a tangent, this line is called a tangent. So the length of tangent is equal, and we can only have two tangents drawn from an external point, right? Similarly, a figure is shown over here. It is showing a chord AB and it is showing a tangent T that meets at external point P. Now again the same property can work over here. PA into PB is equal to PT into PT. So PA into PB is equal to PT squared. Next, we are having a circle and we are having a segment, and we are having certain angles on this circumference. So if we are having any angle on the circumference on the same segment, these angles will be equal. So in this same segment, if I draw this angle, these angles will also be equal. So this angle is equal to this angle is equal to this angle is equal to this angle, because they are sharing the same segment. Next is if we are having a circle and we are having a segment, and this segment makes an angle X at the center, and again this segment makes an angle Y at the circumference. So it is equal to X is equal to 2Y. Very important. X is equal to 2Y. So the angle subtended by a segment at center is twice the angle subtended by this segment at the circumference, correct? So friends, these are some of the properties which need to be known to you and which need to be learned by you in case you are sitting for any exam that is a competitive exam, right? In next lecture, I'll be giving you a small assignment on these figures, and we'll see how easy it is to answer those figures if we know these possible properties. So if you like my video, just subscribe it, share it, read it, and just memorize it. Thank you.